Hello, I'm SA, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
The early decades of the 20th century presented Japan with a unique set of challenges and opportunities. The nation, rapidly modernizing and seeking its place on the global stage, grappled with the fundamental need for efficient, affordable personal mobility. For the vast majority of the populace, travel remained a laborious affair, often dependent on bicycles, animal-drawn carts, or the limited and often inaccessible public transport systems that were themselves in their infancy. The industrial landscape, while showing promise, was still developing, with many manufacturing processes reliant on imported technologies or artisanal methods that struggled to meet the growing demand for standardized, mass-produced goods. Within this environment, the identification of practical needs and the development of robust, accessible solutions became paramount. Michio Suzuki emerged as a figure deeply attuned to these prevailing conditions. His early career was forged in the crucible of manufacturing, a domain where ingenuity was often born from necessity. Before his name became synonymous with automotive innovation, Suzuki dedicated himself to the intricate world of textile machinery. This was no casual pursuit. It was an immersion into the very heart of mechanical engineering, where precision, reliability, and efficiency were the cornerstones of success. The textile industry, a vital component of Japan's burgeoning economy, demanded machinery that could operate continuously, produce consistent quality, and withstand the rigors of demanding production schedules. Suzuki's approach to these early challenges was characterized by a profound pragmatism and a keen eye for detail. He recognized that innovation did not always require the invention of entirely new principles. Often, the most impactful advancements stemmed from the astute adaptation and refinement of existing technologies. His work with looms and spinning machines involved a deep understanding of mechanical linkages, power transmission, and the optimization of material flow. He meticulously analyzed the operational shortcomings of contemporary equipment, identifying areas where improvements in design or material selection could yield significant gains in productivity and durability. The problems of the time were stark. Textile factories required machinery that was both robust and capable of intricate, repetitive tasks. Downtime due to mechanical failure was economically devastating, and the quality of the finished fabric depended entirely on the precision of the looms. Suzuki's solutions involved a thorough re-engineering of key components. He focused on improving the strength and wear resistance of gears and bearings, often experimenting with different metal alloys and heat treatments to achieve superior performance. He also dedicated considerable effort to streamlining the manufacturing processes for these machines themselves. This involved developing more efficient machining techniques and establishing quality control measures that ensured uniformity across all produced units. His early ventures, while centered on textile machinery, provided him with an invaluable education in the principles of industrial production. He learned to manage supply chains, to train skilled labor, and to understand the economics of manufacturing at scale. This period was formative, instilling in him a mindset that valued practical application and measurable results. The ability to translate complex mechanical concepts into tangible, reliable machinery was a skill honed through countless hours of design, testing, and refinement. The context of early 20th century Japan amplified the significance of Suzuki's endeavors. As a nation striving for industrial self-sufficiency, the development of domestic manufacturing capabilities was a national imperative. The ability to produce high-quality machinery domestically reduced reliance on foreign imports, strengthening the national economy and fostering technological independence. Suzuki's contributions to the textile machinery sector, therefore, resonated beyond individual factory flaws. They represented a tangible step in Japan's broader industrial development. The universal challenge of creating accessible technology and developing industrial landscapes finds a potent early example in Suzuki's work. His focus on improving existing machinery, making it more reliable and efficient, directly addressed the need for practical, cost-effective solutions. This ethos of enhancing accessibility through thoughtful engineering laid the groundwork for his later, more widely recognized achievements. The principles he applied to textile machinery, understanding user needs, optimizing mechanical design for specific environments, and striving for production efficiency were universal to any field of engineering, and they foreshadowed the direction his career would eventually take. His early success was a testament to a mind that could perceive the intricate workings of machines and envision their potential for improvement, a perspective that would soon turn towards a different kind of personal conveyance. The post-war economic landscape of Japan presented a unique set of engineering challenges, demanding solutions that balanced innovation with pragmatism. Following his foundational work in refining textile machinery, Michio Suzuki's attention turned towards a burgeoning sector that promised to revolutionize personal mobility, the motorcycle. This transition was far from a simple diversion. It represented a profound application of his core engineering philosophy to create reliable, efficient, and accessible mechanical solutions tailored to the specific needs and constraints of his time. The development of powered two-wheeled vehicles in Japan during this era was intrinsically linked to the nation's economic recovery and its growing desire for personal freedom and efficient transportation. The primary engineering hurdle in this new domain was the creation of lightweight, fuel-efficient, and robust engines capable of withstanding the varied and often demanding conditions of Japanese roads. Early motorcycles, both imported and domestically produced, often suffered from reliability issues, excessive fuel consumption, or were simply too expensive for the average consumer. The economic realities of post-war Japan meant that any new vehicle had to offer exceptional value, combining affordability with dependable performance. Furthermore, the prevailing infrastructure, characterized by narrower roads and a mix of urban congestion and rural routes, necessitated vehicles that were agile, easy to handle, and possessed a degree of maneuverability that larger, heavier machines could not offer. Suzuki's strategic embrace of the small displacement two-stroke engine marked a pivotal engineering decision. While four-stroke engines were prevalent in many Western markets, the two-stroke design offered inherent advantages for the context Suzuki was addressing. Its simpler construction, with fewer moving parts, translated directly into lower manufacturing costs and reduced maintenance complexity, critical factors for widespread adoption. More significantly, the two-stroke engine's power-to-weight ratio was generally superior, allowing for the development of compact yet spirited machines. Suzuki's genius lay not merely in adopting this technology, but in refining it to an exceptional degree. He meticulously worked on improving the scatting process, the expulsion of exhaust gases, and intake of fresh fuel-air mixture to enhance efficiency and reduce the characteristic smoke and emissions associated with earlier two-stroke designs. This involved intricate attention to port timing, combustion chamber shape, and exhaust system tuning. The development of these engines was a testament to Suzuki's meticulous approach to mechanical engineering. He understood that achieving high performance from small displacements required a deep dive into the fundamental thermodynamics and fluid dynamics at play within the engine cylinder. This meant optimizing the compression ratio, the ignition timing, and the fuel-air mixture for maximum power output and fuel economy. The pursuit of reliability involved rigorous testing of materials and manufacturing tolerances, ensuring that these small, high-revving engines could endure prolonged use. Innovations in lubrication systems, designed to effectively oil the engine components despite the fuel oil mixture, were also crucial for longevity. Beyond the engine itself, Suzuki's team focused on integrated chassis design that complemented the characteristics of the small displacement power plants. The aim was to create motorcycles that were not only efficient, but also a pleasure to ride. This involved developing frames that provided excellent rigidity and stability without adding excessive weight. Techniques for shaping and joining steel tubing were refined to achieve optimal strength-to-weight ratios. Suspension systems were engineered to absorb the shocks of uneven road surfaces, providing a comfortable ride and maintaining tire contact for secure handling. The ergonomics of the motorcycle, from handlebar placement to seat design, were carefully considered to ensure ease of control and rider comfort, especially for longer journeys or in stop-and-go traffic. A prime example of this integrated approach was the development of early models that became synonymous with accessible motorcycling in Japan. These machines were designed with the understanding that they would serve as primary transportation for many, used for commuting, running errands, and even carrying passengers or light cargo. This practical focus informed every aspect of their design, from the inclusion of sturdy luggage racks to the development of durable tires capable of handling various road conditions. The engineering of the transmission and drivetrain also played a crucial role, ensuring smooth power delivery and efficient use of the engine's output. Suzuki's engineers paid close attention to gear ratios, selecting them to provide a good balance between acceleration for city riding and a comfortable cruising speed for open roads. The success of these early Suzuki motorcycles was not solely a product of individual technical breakthroughs, but of a holistic engineering vision. It was about understanding the user, the environment, and the economic realities, and then synthesizing these factors into a cohesive, functional, and desirable product. The principles of lightweight construction, efficient engine design, and user-centric ergonomics that were honed during this period would become enduring hallmarks of the Suzuki brand. The ability to extract maximum performance and reliability from minimal displacement and weight was a core competency forged in these formative years. The modern relevance of Suzuki's contributions in this era is significant. The enduring principles of two-stroke engine efficiency, particularly in applications where simplicity, low weight, and high power-to-weight ratios are paramount, continue to be explored and refined. While emissions regulations have led to a decline in their use in larger vehicles, advancements in direct injection and other technologies have breathed new life into the two-stroke concept for specific niches. Furthermore, the engineering philosophy of achieving sophisticated performance through elegant and cost-effective design remains a guiding principle in product development across numerous industries. The Suzuki approach demonstrated that one could achieve remarkable results by deeply understanding and optimizing fundamental mechanical principles, making advanced capabilities accessible to a broader population. This era marked a critical step in solidifying Suzuki's reputation as a manufacturer capable of delivering practical, high-quality engineering solutions that met the evolving needs of a dynamic society, setting the stage for its subsequent ventures into more complex automotive engineering. The societal landscape following the mid-20th century presented a compelling imperative of the democratization of personal mobility. As economies rebuilt and aspirations for individual freedom and convenience grew, a substantial segment of the population sought affordable, practical, and efficient means of transportation. This burgeoning demand for accessible personal vehicles presented a unique set of engineering and manufacturing challenges, a complex puzzle that Michio Suzuki and his burgeoning enterprise were uniquely positioned to address. The era called for an automobile that was not merely a luxury item, but an essential tool for daily life. A vehicle that could navigate crowded urban environments with ease and offer economical operation for the average household. The creation of a people's car in this post-war context demanded an engineering philosophy that prioritized judicious resource allocation and ingenious problem solving. The prevailing automotive giants often focused on larger, more powerful vehicles, leaving a significant market gap for smaller, more economical options. Suzuki's vision centered on bridging this divide. The core problem was one of scale and cost: how to engineer a reliable, functional automobile that could be produced at a price point accessible to a broad consumer base. This involved a deep dive into material science, engine design, and efficient manufacturing techniques, all while maintaining a commitment to the fundamental principles of durability and performance that had begun to define the Suzuki name. The development of early compact vehicles, most notably the Suzuki, represented a profound engineering response to these societal needs. This pioneering model embodied a meticulous approach to miniaturization and weight reduction, crucial elements for achieving superior fuel efficiency and enhanced maneuverability in congested areas. The engineers grappled with the inherent trade-offs associated with creating smaller engines. The objective was to extract robust performance from compact powerplants without compromising reliability or exceeding cost targets. This led to innovations in the design of two-stroke engines, a technology that offered a favorable power-to-weight ratio and mechanical simplicity, making it an ideal candidate for a lightweight, affordable automobile. The meticulous balancing of components, the careful selection of materials, and the optimization of combustion cycles were all critical to realizing the potential of these smaller displacement engines. The choice of materials played a pivotal role in the Suzuki's design philosophy. To achieve the desired lightness and cost-effectiveness, Suzuki engineers explored the use of lighter alloys and pressed steel components. This required a sophisticated understanding of metallurgy and manufacturing processes to ensure structural integrity and durability while minimizing the overall mass of the vehicle. The challenge was to create a chassis and body that could withstand the rigors of everyday use without the substantial weight associated with traditional automotive construction. This pursuit of lightness was not merely an academic exercise. It directly translated into improved fuel economy, reduced wear on components, and a more responsive driving experience, all highly valued attributes for the target market. Manufacturing processes were equally subject to intense scrutiny and innovation. To bring the Suzuki to market at a competitive price, Suzuki implemented streamlined production techniques. This involved optimizing assembly lines, improving tooling, and embracing efficient fabrication methods. The goal was to achieve economies of scale that would make the vehicle affordable without sacrificing quality. This required a holistic view of production, from the sourcing of raw materials to the final assembly, with every step analyzed for potential efficiencies. The success of this approach hinged on the ability to produce consistent, high-quality components in large volumes, a testament to the company's growing manufacturing prowess. The technical hurdles associated with miniaturization were significant. Engineers had to ensure that every component, from the transmission to the braking system, was scaled down appropriately while retaining its essential functionality and robustness. The design of a compact suspension system, for instance, needed to provide a comfortable ride and stable handling despite its smaller size and lighter, load-bearing capacity. Similarly, the development of an effective braking system for a lighter vehicle still demanded precision and reliability. These were not simple reductions in size. They were intricate engineering problems requiring careful calculation and innovative solutions to ensure that the smaller scale did not equate to diminished performance or safety. The impact of these really compact vehicles extended far beyond their immediate market success. The Suzuki and its successors established a precedent for the compact car segment, demonstrating that personal mobility could be achieved through ingenuity and a focus on user needs. The engineering principles honed during this period, prioritizing lightweight construction, efficient powertrain design, and cost-effective manufacturing, became enduring hallmarks of the Suzuki brand. They laid the groundwork for a philosophy that would continue to guide the company's development, making advanced engineering accessible and practical for a global audience. The commitment to creating vehicles that were both functional and affordable resonated deeply with consumers and fundamentally shaped the automotive landscape, proving that impactful innovation could emerge from a dedication to addressing fundamental human needs with elegant, efficient solutions. The lessons learned in miniaturization and cost optimization during this formative period would prove invaluable as Suzuki continued its journey, solidifying its reputation as a manufacturer capable of delivering sophisticated engineering within accessible parameters. Michio Suzuki's career stands as a testament to the profound impact of a singular vision grounded in practical engineering and an unyielding dedication to the user. His influence extends far beyond the assembly lines and design studios. It resides in the enduring principles of ingenuity, efficiency, and accessibility that he championed. These core tenets, forged in the crucible of post-war industrial reconstruction and refined through decades of market evolution, established a global automotive identity synonymous with intelligent design and reliable performance. Suzuki's approach was fundamentally about translating complex engineering challenges into tangible benefits for everyday people, a philosophy that resonated globally and continues to shape product development today. The unwavering commitment to practical engineering solutions defined Suzuki's operational ethos from the earliest days. The focus was on creating products that served a clear purpose, addressing specific needs with elegant and robust designs. This was evident in the meticulous attention paid to every component, ensuring not merely functionality, but also durability and ease of maintenance. The company's ability to adapt to evolving market demands was another crucial element of its success. As global economies shifted and consumer preferences diversified, Suzuki demonstrated a remarkable agility, consistently reorienting its production and innovation efforts to meet new challenges. This adaptability was not a reactive measure, but a proactive strategy, anticipating trends and developing solutions that often set new benchmarks for the industry. The pursuit of miniaturization, for instance, which began as a necessity for economic viability, evolved into a core competency, allowing Suzuki to excel in segments where larger, more resource-intensive vehicles were less suitable. This strategic mastery of scale and efficiency allowed the company to navigate economic downturns and competitive pressures with remarkable resilience. The foundational role Michio Suzuki played in establishing a globally recognized automotive brand through engineering excellence cannot be overstated. He understood that true brand loyalty was built not on fleeting marketing campaigns, but on the consistent delivery of quality and value. This meant a relentless pursuit of improvement in every facet of the manufacturing process. The engineering prowess cultivated within Suzuki became its most powerful differentiator. It fostered a culture where innovation was intrinsically linked to practicality, where sophisticated technical advancements were always filtered through the lens of user benefit and affordability. This resulted in vehicles that were not only mechanically sound, but also intuitively designed, making them approachable and enjoyable for a wide spectrum of drivers. The legacy of this engineering-centric approach is a brand that has earned the trust of millions worldwide, a trust earned through decades of dependable performance and thoughtful innovation. The principles of ingenuity, efficiency, and accessibility that characterized Michio Suzuki's career, offering during insights into modern product development. In an era increasingly concerned with resource conservation and sustainable practices, Suzuki's early emphasis on creating lightweight, fuel-efficient vehicles feels particularly prescient. His philosophy underscored the idea that environmental responsibility and economic viability were not mutually exclusive, but rather intrinsically linked. By prioritizing efficient powertrain design and intelligent material usage, Suzuki demonstrated that it was possible to achieve high performance and broad appeal while minimizing environmental impact. This forward-thinking perspective, rooted in practical necessity, continues to inform strategies for developing products that are both desirable and responsible. Furthermore, Suzuki's dedication to user-centric design remains a potent model for contemporary innovation. The company's success was predicated on a deep understanding of consumer needs and desires, translating them into products that seamlessly integrated into users' lives. This involved not only the functional aspects of a vehicle, but also its overall usability, its intuitive controls, and its comfortable interior environments. The focus was always on enhancing the user experience, making the product a reliable and enjoyable companion. This commitment to the end user, to understanding the human element behind every purchase, is perhaps the most profound and lasting lesson from Michio Suzuki's remarkable journey. His legacy is woven into the fabric of the automotive industry, a continuous reminder that true innovation flourishes when driven by clear vision, a commitment to excellence, and a genuine understanding of the people it serves. The enduring influence of his pragmatic yet forward-thinking approach to engineering continues to inspire, proving that impactful and lasting success is achieved through a steadfast dedication to creating value and enhancing the lives of individuals through thoughtful, efficient, and accessible design.
We really appreciate you tuning in to this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.